So, good morning, everybody. In the last lecture, we have seen the basic principle of counting, product rule, sum rule, addition rule, and subtraction rule. So, today we will explore here the concept of permutation. But before that, we will see here one definition to use here in permutation. So let us see the first definition. It is a factorial. So first we can define the factorial notation. So for a non-negative integer n, we define n factorial, and we can read it as a n factorial, and it is given by n factorial is equals to n into n minus 1 into n minus 2 and so on up to 2 into 1. So this is the definition of a factorial of n. So from the above definition, we know that the factorial of 0 is 1 and the factorial of n or n factorial is, we can write it is equals to n into n minus 1 factorial. Now we will illustrate here example on this definition. So find the factorial of 5. So here the factorial of 5, by definition we can write it is 5 into 4 into 3 into 2 into 1, and it is 120. So the factorial of 5 is equals to 120. The second example is 7 factorial divided by 3 factorial. We have to evaluate this one. So in the numerator we can find the factorial of 7, and it is 7 into 6 into 5 into 4 into then 3 factorial we will write here, because in the denominator it is 3 factorial and then it is cancel out. We get the answer is 840. So see again the same example or a parallel example to find the 10 factorial divided by 3 factorial into 5 factorial. Now you can apply the definition of a factorial to find out the factorial of 10, and you can expand it only with up to 5 factorial. So it is written here 10 into 9 into 8 into 7 into 6 into 5 factorial, because already 5 factorial is in the denominator. That's why we stop here expanding it, divided by 3 factorial into 5 factorial as it is, and then you can cancel 5 factorial from numerator also and in the denominator also, and this is very simple calculation. We get the answer of 10 factorial divided by 3 factorial into 5 factorial, and it is 5040. Yes. So by using the definition of a factorial, you can find out or you can solve some examples. So let us see here the next example. It is a result to prove that 2n factorial upon n factorial is equals to 1 into 3 into 5 dash dash up to 2n minus 1 into 2 raised to n. So this we have to show. So to prove this result, we will take here the left hand side and show the result on right hand side. So you can take the left hand side, it is 2n factorial upon n factorial. So by definition of a factorial, we can write here 2n factorial as 2n into 2n minus 1 into 2n minus 2 and so on up to 1. So just you can apply the definition of a factorial, divided by, you can write that n factorial as it is, and after that if we see the terms in the numerator of second step, if you observe already it is written is 2n minus 1, then the term you can write 2n minus 3, 2n minus 5 and so on up to 3 into 1, and in the second square bracket we can adjust the terms into 2n minus 2 into 2n minus 4 up to 4 into 2 and so on. Okay, so just you can separate these terms, divided by n factorial as it is. Now in the next step, it is equals to, if you observe, you can find out here 2 raised to n common from the second square bracket and write the remaining terms, and then you can cancel out it. We get 1 into 3 into 5 up to dash dash up to 2n minus 5 into 2n minus 3 and so on into 3 into 1 bracket close 2 raised to n into n factorial, and we get the desired result, and it is the right hand side of your required result. So in this way we will prove the result 2n factorial upon n factorial equals to 1 into 3 into 5 up to the up to so on into 2n minus 1 raised to 2 raised to n. Yes, so I think you have understand the definition of a permutation very well, and we will illustrate here some example and one result on this definition. Now we will see here the next concept is a permutation. So what is meant by a permutation? So first we can write here the concept of permutation or a definition of a permutation. What is meant by a permutation? So let A be a set of n distinct elements. So we can consider here A is a set of n different distinct elements. So permutation of these elements is any ordered arrangement of R elements taken out from n elements. So where R be a positive integer, it means that a more appropriate description of this permutation is an arrangement of all or a part of a set of elements in a specific order. Just you have to order it. So here one example is also given. For example, if you take the set A is equals to the 3 elements x, y, z, and if you have to take out the permutation of these elements of set A, so permutation of one element means just you have to order one element of these 3 elements x, y, z. So there are how many permutations if you take the one element of a set AR, then it shows that the 6 permutations of 2 elements of set AR is xy. So this is the first permutation, then xz, yz, yx, zx and zy. So after that, if you take the 3 elements of that set A and if you take the permutations, then there are 6 permutations are find out. So that 6 orders or arrangement is also shown here. It is xyz, yzx, xzxy, xzy, yxz, zyx. So the number of permutations of R elements taken out from n is given here. Yes, so I think you know the simple meaning of permutation is it is the arrangement of R elements in a particular fashion. Yes, so this is the meaning of a permutation. Now let us see here one result or a theorem on this permutation. So the statement of this theorem is for a positive integer n and R with R is less than or equals to n, we have to prove here the result NPR. So this is the notation of a permutation. NPR is equals to n into n minus 1 into up to so on into n minus R plus 1 is equals to n factorial upon n minus R factorial. So this is a very important result of a permutation. So this is also we can call it as a formula for a permutation to find the number of permutations in your required set. Yes, so just you can remember that NPR is equals to n factorial upon n minus R factorial. So here we have to prove this result. So let us see. So proof of the theorem. So to construct the number of permutations of R elements from a set of n distinct elements, so we have to arrange these R elements out of n elements by considering the choice, yes, for each position of an element. So are you got my point? Just you have to arrange R elements out of n elements by considering the choices of each position of an element. So for the first place, we have to choose the first element in n1 ways because already there are n elements in that set. Yes, that's why if we choose one element or first choice, so we have to choose first element in n1 ways. After placing one element in the first position, how many elements are remaining? So for the second element, there are n minus 1 ways, because already one element is removed. It is in the first position. Yes, that's why if we have to choose the second element, we can choose that second element in how many ways? N minus 1 ways. So after that, if we have to choose the third element, then you can choose that how many ways? It is n minus 2 ways. And if you continue in this manner, or you can continue this process until we have placed the rth element. And how many ways you can arrange that rth element is n minus r minus 1 ways. Yes. So therefore, if we collect these, and by using the multiplication principle, or we can call it as a product rule, we can write that r elements which are chosen in this way, because all these are independent. So n into n minus 1 into and so on into n minus r plus 1 ways. Yes, and hence npr is, you can write it is equals to that n into n minus 1 into dash dash up to n minus r plus 1. Yes, after that you can multiply numerator and denominator by n minus r factorial to right hand side. So we get this second step or second term. Then after multiplication, so let us see what we get here. It is n into n minus 1 up to n minus r plus 1. So that is into, if we observe, just you can write the definition of n factorial in the numerator. Yes, divided by n minus r factorial. So if we observe the numerator, it is the definition of a factorial of a n. So you can simply write it is n factorial and divide by denominator as it is. So if you observe that, just you can selecting the first element, second element, third element and so on r element, and by using the product rule you can write the permutation of r elements taken out from n elements. It is equals to n factorial upon n minus r factorial. Yes, so this is the proof of this required result. Now let us see what happens if we put r element, it is equals to n. It means that it is easy to express that the number of permutations of n elements taken from n distinct elements, means all the elements. So this is the remark. Then we can calculate npn. That means you can replace r by n in your previous result. Yes, therefore by the previous result, npn is equals to n factorial upon n minus n factorial. So it is n factorial upon n minus n factorial is equals to 0 factorial, and you know the value of 0 factorial is 1, and that's why npn is n factorial. Yes, so this is the remark for if you take r is equals to n. Now let us see here the example on this concept. So the statement of this example is, if there are 6 people, how many ways can they be arranged in a line? So we have to arrange these 6 peoples in a line if 2 specific people must always be next to each other. So what is the condition? We have to arrange 6 peoples in that way. All these are arranged in a line if 2 specific people must always be next to each other. Yes, so this is the condition on arranging these 6 peoples. So how to find the solution of this one? So treat any 2 people or specific people as a single unit. Yes, we have to assume first that it is a single unit. Therefore, there are how many peoples are there? 6. And if 2 specific people, if you take it is a single unit, then how many peoples are there now? So there are 5 units are there to arrange these 2 peoples and other 4 peoples. Are you got my point? Yes. So this is shown here. So these 5 units can be arranged in a 5 factorial ways. So within the 2 persons unit, the 2 people can be arranged in 2 factorial ways. Therefore, the total number of ways to arrange these 6 peoples is how many ways? It is shown here, 5 factorial into 2 factorial. You can apply the multiplication rule. We get the answer is 256. 40. Yes, so this is the you can arrange 6 peoples in a line with 2 specific peoples are each other, yes, next to each other. Now let us see here the next example. So listen carefully, the example is very interesting. How many permutations can be made from the letters of the word birthplace? So if you observe, we have to make an arrangement of these letters which are in this word birthplace. Yes, so how many letters are there in this word birthplace? If you count, it is, so it is given in the solution. So there are 10 letters in the word birthplace. Yes, and also if you observe, each and every letter is not repeated. Yes, so all these letters are distinct, keep in mind. So after that you can assume that, suppose A be the set which contains these are the letters, we can call it as elements. These are 10 elements which are the letters of the word birthplace. So we have to find the permutation of these 10 letters and we have to take out that 10 letters. Yes, so question is already it is given that we have to find the permutation of all these letters. Yes, so see, you know the result on a permutation, npn is equals to n factorial. We have to find out or we have to arrange 10 letters out of 10, and that's why it is a 10p10 is equals to 10 factorial. Just you can find out the factorial, we get the answer. Yes, so there are 36,28,800 distinct permutations of the letters in the word birthplace. So you can arrange these letters in 36,28,800 ways. Yes, so now let us see here this example. So read carefully. So see this example. How many permutations can be made from the letters of the word formula? So the conditions are here, or that question is, the first question is 4 letters are used to be together. Means we have to arrange 4 letters out of, how many letters are there? 1, 2, 3, 4, 5, 6, 7. Out of 7 letters, 4 letters are used together and we have to find out the permutation. Second question is, all letters are used but first letter should be a vowel. Yes, so you know the vowels are, how many vowels are in the 26 letters? Yes, there are 5 vowels, A, E, I, O, U. So we have to use the first letter as a vowel and then we have to find out the permutations. Yes, the third condition is, or third question is, all letters are used but first 2 letters should be vowels. Yes, and the fourth question is, 4 letters are used but first letter should be vowel. So in this way you can find out the solution. So the first question is, we have to find out the permutation of 4 letters together. So the word formula consists of 7 unique letters. These are not repeated. All these letters are different. So we have to find out the total permutation of 4 letters taken out from 7 letters. So you can use that formula, npr is equals to n factorial upon n minus r factorial, and just you can calculate, we get the answer is 840. So hence there are 840 permutations of 4 letters taken from 7 letters of this word formula. Yes, so see here the second question. What is the second question? We have to find out the permutation if the first letter is a vowel. Yes, so already you know there are 7 letters. So now the condition is we have to take the first position is a vowel. So how many vowels are there in this word formula? So there are 3 vowels, and what are those? The first is O, U and A. These are the 3 vowels which are in the word formula. So therefore the first letter can be choose out of 3 vowels. Yes, are you understand my point? There are 3 vowels. Out of these 3 vowels we have to choose the first letter out of these three in how many ways? 3 ways. Yes. After that, remaining 6 letters are choose out of 6 letters in 6p6 ways. Are you understand? Because once you can choose the first letter as a vowel, there are 7 letters are in the word formula. Then there are 6 remaining letters you can arrange in a 6 ways. It is 6p6 ways. So the total permutation is 3 because 3 vowels are there, and remaining 6 you can choose from 6 letters. It is 6p6 ways, and just you can find out this calculation we get, so that 2160 permutations where the first letter is a vowel. Yes. So I think you can understand very well this one. This. Yes. So this is all about how you can find or how you can apply the result of permutation. Yes. After that we will stop here, and in the next lecture we will see some examples on permutation. Okay.